This conference will now be recorded.
Good lunchtime, everyone. Thanks very much for joining us. Um, I retired from the university for the second time about 5 years ago, but I've continued to be involved with the creation of these little apps that you're going to be seeing some of today. My degrees are in meteorology. I have a bachelor's and a master's, and in between I worked for the Weather Service for a few years. And then basically, after my master's degree, fell into programming for the meteorology department, helping Don Johnson's grad students, and eventually moved over to space science, where I was involved in a lot of visualization projects. And in the early 90s, we got a new professor in the Department of Meteorology, Steve Ackerman. And Steve had some really interesting ideas about what he would have liked to see the web do. At the same time, I moved from Fortran and C programming to this new language called Java for a new visualization project. And in the late 90s, got connected with a project under the Weather Service for their training for forecasters in satellite meteorology. And this evolved then into creating these applets for Steve Ackerman, because Java had this promise of write one time and run everywhere, because they wanted Java to run in all the browsers. Well, we did a lot of that work. A lot of Java applets were out there, but eventually the browser manufacturers decided they were going to kill Java applets in the browsers. So we started a slow migration into using Flash. That didn't last very long because this new technology called HTML5 came out. And we then started converting things over from Java and a few of the Flash applets into this environment under HTML5, which is really a collection of HTML, CSS, and JavaScript. JavaScript being the key here, because the browser manufacturers sort of have gotten into a battle over who's got the fastest interpreter for JavaScript. So that part of it has been really, really helpful for the kinds of things that we do. I've left on the page here 3 URLs, and I'll get back to the first one. I want to go to the bottom one first, just to show you this is what we started with, and this is a page that's grouped by topic. So if you look, I'm scrolling down through here, and if you look at the topics, you'll see occasionally it'll say an HTML5 version, and I'm going to just pop one up here. This was one of the original ones that Steve Ackerman and I did, where we wanted to give some basic ideas about a particular concept, namely albedo. And so we made this little planet here that you can move around and then change the albedo of the planet. We overloaded this by allowing the students to change the scaling and the units of temperature. Subsequent to this, we kind of learned our lesson not to do too much of this stuff, though, because too many options meant that they might miss the point. Because of the popularity of the HTML5 web apps, I created a page which only lists the HTML5 applets, but it's in no particular order. I suppose I should go back and rearrange it by topic as we did before. But again, the big descriptions that are out there are on that first page that I showed you. But probably the one I'm going to focus on today is the one that Margaret put together as part of some WeatherFest things for outreach activities and the AMS WeatherFest. So what you see here are thumbnails from these web apps that are available on the web, plus the other ones that are available. And I'll just scroll down here and you can see a whole bunch here. But let me just jump in and show you the kinds of things that we're doing. So here's a very basic one that allows people to create clouds and showers. And what I'm doing here is I'm manipulating the temperature and dew point temperature in the lower levels of the atmosphere. And the idea here is to allow students to create a thunderstorm, or if I go up higher and drag that over, to see what happens if you get an inversion in the atmosphere. Again, very basic concepts, but it allows people to experiment and play with things. Following on that one, this guy here is used to determine what type of precipitation will fall. And this is actually got some science behind it, created by the science operations officer at the La Crosse Weather Service office. Again, here I'm dragging the temperature of the cloud And you'll notice when I saturate it, we get more stuff falling out of the cloud. But because it's below freezing, what we're getting is ice crystals. If I change the mid-level, and I'll change both the temperature and the wet bulb temperature here, what happens is as the crystals fall, they turn into liquid, but then that part of the air gets cold enough so that you get sleet in the middle part of the atmosphere. Again, this allows you to experiment and play and learn the types of conditions that are evolved in the types of precipitation that you see on the ground. Part of this also we wanted to emphasize was experiential things that people experience every day. For example, when you have a thunderstorm, you get lightning and you get thunder. We have the ability on this one to enable the thunder sound so that even though the little person changes shape if you don't have sound, but you can hear thunder. And the idea here is to learn the rule, the 5-second rule. There's also the concept that if you even are a ways away from the thunderstorm, you still might get hit by the bolt from the blue. And so again, we're trying to teach people a little bit of the concepts that are involved. Rainbows are another interesting one. People love to see rainbows. Here, you can take the person and move them back and forth, which really is the distance from the precipitation shield. You can change the angle of the sun, again, to teach people and let them experiment with that kind of thing. We can change to the secondary rainbow as well. If I can get my mouse over there. Here I'm outside of the scope, but if I move this up, then I can start seeing the dimly lit secondary rainbow. If I change to single drop mode, then you get to see the reflection and refractions inside the drop and what causes the rainbow. Again, the tools are designed to be integrated into classroom work. We don't have much curriculum around most of these because we want people to be able to experiment for themselves and build it into whatever they'd like to teach. Another popular one, when we take these out to educational shows, particularly science nights at schools, is this one where it's building a livable planet. And we take 3 elements, water, atmosphere, and clouds, and we allow the people using this to add those to our planet. So here I'm clicking on the water and I'm adding some water. And the idea, if you look down at the bottom, is to get a temperature of about 15 degrees Celsius, and that makes a livable planet. Inside this, we're actually running a model, which is why if you look down there at the bottom, as I add stuff to that, the temperature takes a while to settle down. One of the rules, though, is that you have to add at least 3 clouds. So people try and do it without adding any clouds, and that just doesn't work. So we'll add a little bit more atmosphere here. Now I've made it way too warm. So I'm going to add a cloud, maybe 2 clouds to try and get it down to temperature. And one of the most frustrating things that people run across is just what I'm doing here. It's this iteration back and forth, and you don't quite get it, which is really too bad. And finally I did. It took me 2,500 million years to make this planet. So a lot of fun involved in that one. We've had
so Tom, can I interrupt and have 30 seconds? So yeah. We take these web apps to AMS Weatherfest, and that particular one, by the way, Lynn Chambers, I think, commissioned it or had the idea for it. But anyways, we have these parents with their kids doing the applets, and there was this mother that wanted her daughter to go to another part of the exhibit, and she said, "Come on, you know, Susie," or whatever her name was, and Susie like stopped, threw her arms down, turned to her mom and said, "Mom, I'm making a planet here." It was so funny.
Yeah, it was really good. Gave us all a really.
There's a question in the chat box that says any hurricane models.
Oh yeah, not a model. Well, I have a model, but I also have a demo of a hurricane. Let me just pull this one up right here. So what we allow for is this low pressure area to move across through the Atlantic, and you can steer it by moving the high around as I'm doing here, and you'll notice the category changed. I can also, if I wanted to drag it somewhere, I can manually drag it and not let the flow. The flow here is representative from the seasonal average, and I can change between seasons, and you'll notice the sea surface temperature changes. I can move this up into the Gulf where it's really warm, and you'll notice we're making pretty good Category 3 hurricane there for a while. So this is one thing, and again, as you move the high around, it does change the flow pattern. Again, let people get the idea of what the mechanisms are for moving and intensifying hurricanes. We do have a very simple model that's out there, which I'm going to allow it to the questioner to go find because it's listed on one of those web pages as a simple hurricane model involving the temperature gradient and pressure gradient, I guess. One more before my time is up here, Margaret, if I can. We wanted to teach people about the seasons, and so we created this web app. It actually started as a Java applet. We have a few too many controls here, but I'm just going to zip through them. It will start up with the current date. So here you see we're late in March. I can scroll this pointer around here and it'll actually move the position of the planet around. If I don't like that view, I can switch to a top view instead. I can also rotate the planet. And then I can set it into orbit. And this orbit is actually moving in according to the rotation of the planet. So after 365 rotations of the planet, the little Earth there will have gone completely around the circle once. This is kind of boring. So we have the faster orbit, which actually accelerates the orbit. And as it moves through the equinoxes, it will show that on there. I've just clicked to show the insolation curve over here. The blue curve is the hours of sunlight, and then the magenta curve is the solar insolation. One of the more interesting parts of this is this map that we can put up here, which is then showing the lightness and darkness of parts of the planet. And let me just stop the orbit here for a second. So we're stopped at sometime in early September, it looks like, and this is what the sunrise and sunset would look like. If I stop the rotation and then start the faster orbit, this is what would happen. Mark, can you get that, Max?
I got it.
Okay. Sorry about the phone call there. You can see that as the planet moves around without spinning, the sun was actually going the other direction from west to east. Kind of interesting. So again, the idea is to teach some basic concepts. We have a variation of this also involving the Milankovitch cycles, dealing with climate too. So that ought to be it, Margaret. I think my time is up.
Yeah, I'm not doing very good. Actually.
Margaret?
Yeah, he's on.
Margaret is not there, so I can continue.
Live right now, so I'll call you when he's done.
This one we use to.
Oh, I'm sorry, I was muted. Go ahead.
Darn.
I was talking, but you were ignoring me.
Can I do this one?
Go ahead.
Okay, so this one helps people learn about what the phases of the moon are all about. And I actually went to an AMS meeting once and I started asking some of the people there what causes the phases of the moon. And I was really horrified to learn how much misinformation and diseducation there was about the phases of the moon. So we created this one to help people understand what the phases of the moon are all about. And again, you can have the oblique view there or a top view, and I'm going to leave it there. The idea here is that you click on the moon and you rotate the shadow around until you think you got it right. And when you do, that's great. You can say, check my answer, and then it tells me, oops, not right. So then I can click it over here because I know that's the right answer. And I'll move the moon again, and I'll get the right answer there.
So
And
Tom,
after-
we should stop
Okay.
because we're up to our time. May you please put on the Milankovitch one just to view while I ask you some questions from the chat box. The reason I want you to bring this one up is that you can see that it's clean selected. Clean is part of ESIP education. So this has made the clean collection. And also Luann Dahlman, who is part of ESIP, put some feedback into this one with you, I thought, as you were doing it.
Yeah.
I wanted to mention the two ESIP connections there on this one. This one's super powerful also. So one question in the chat box, Tom says, we're working on developing story maps through ArcGIS apps. Can these be embedded in these kind of resources?
Anytime you can embed HTML into whatever toolkit you're using, then you can do this. This is all HTML and JavaScript based. There are, in some cases, we've had to actually build the imagery into the JavaScript because people wanted to run them standalone rather than through a web server. But if you have specific ones you want, just send me an email and I can get you the code and any supporting image files. Like this one has got a background image with the sun, and it's got the Earth image there that it needs to spin around and things like that. Okay.
All right. Any questions from anyone? You can ask it audibly. Okay. Oh, I see. Tamara said that. Tamara mentioned that the Clean Collection might need to update their link. And then the person who asked about the hurricane model says, thanks, I'll go look for the one. That was Shelley Olds. All right, I think that we've got all the questions and answers. Thank you so much, Tom, for presenting today. You guys can tell we just started here. There's a lot to play around with.
Yep, it's a lot of fun too.
All right, bye everyone. Thanks for tuning in. See you next week in Out to Lunch. Thanks, Tom. Bye.
Thanks, Tom.
Bye-bye.